one and all. Myself Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So in today's lecture, we are going to learn uniform plane waves in lossy and practical dielectrics. So this uniform plane waves are nothing but electromagnetic waves, and the propagation of these electromagnetic waves in the dielectric media we are going to learn in this particular lecture. Right? So before going to discuss about the wave, how the electromagnetic wave is propagating in the different cases of dielectric medium, let me introduce how the electromagnetic wave motion in the different media, means how the characteristics of the electromagnetic wave are to be varied in different media will let us know first. Then we'll move on to the electromagnetic wave propagation in dielectric medium. Right? So first, electromagnetic wave motion in the different medium. So for the free space medium means the characteristic parameters. So in order to calculate or in order to analyze the wave motion in different media, we need to consider three parameters as sigma and epsilon and mu, where sigma is said to be conductivity of that medium, and epsilon be the permittivity of the medium, and mu be the permeability of the medium. Right? So for a free space medium, sigma equal to 0 and epsilon is to be considered as epsilon naught and mu is to be considered as mu naught. Means sigma equal to 0. There is no conductivity. Means for a free space medium, we have to consider the three following parameters as sigma equal to 0, epsilon equal to epsilon naught and mu equal to mu naught. In general, we know the formula for the epsilon is given by epsilon naught into epsilon r, where this epsilon is nothing but permittivity of the medium, and it is given by, or it is the multiplication factor which yields us, it is the multiplication between permittivity of the free space medium and permittivity of that relative material, relative permittivity. Right? So for a free space medium, this epsilon r is replaced by 1, hence epsilon is considered to be as epsilon naught. That's why for a free space medium, epsilon is equal to epsilon naught, and similarly for mu, means permeability of the material is given by mu naught into mu r, where mu naught is said to be permeability of the free space medium and mu r is relative permeability of that material. Right? So for a free space, mu r is equal to 1, hence mu is replaced by mu naught. As we know that mu naught value is mu naught equal to 4 pi into 10 power minus 7 Henry per meter, and similarly this epsilon naught value is given by 8.854 into 10 power minus 12 Farad per meter. Right? So as we know that epsilon naught and mu naught, hence for a free space medium, characteristics are given by sigma equal to 0, epsilon equal to epsilon naught, and mu is nothing but mu naught. Right? And similarly, so in order to analyze on the next medium called dielectric medium. So for a dielectric medium means generally the materials are broadly classified into three categories according to the term called sigma, conductivity of the material. So if sigma equal to infinity, if sigma equal to 0, and it is ranging from 0 to infinite. Right? If sigma equal to infinity case, material is said to be conductor or metal, and sigma equal to 0 is said to be insulating material, also called as dielectric material. Also called as dielectric material. Right? And for a semiconductors, the range will be in the conductivity which is lies between conductors and the insulators or dielectric materials. Right? So in this case, we are going to consider two different cases of dielectric medium, as one is lossless dielectrics and lossy dielectrics. Right? So for a lossless, as the name resembles us that lossless indicates there is no loss in the signal. Loss is represented with attenuation constant as alpha. Why? Because as we know that amplification means increasing of the amplitude, whereas attenuation is nothing but reduction in the amplitude. So amplitude is going to reduce, hence the constant is denoted with alpha, called attenuation constant, right? So if alpha equal to 0, then sigma equal to 0, hence the medium is said to be lossless dielectrics or perfect dielectrics, right? So in order to analyze the wave, the motion in the lossless dielectric medium, we need to consider these are the following assumptions. Sigma equal to 0, epsilon equal to epsilon naught into epsilon r, and mu is nothing but mu naught into mu r, and condition which we are going to consider for the dielectric medium is sigma is far lesser than that of omega epsilon. Means at very low conductivity case, at very high frequencies case, medium behaves as dielectric medium. So condition which we are going to consider for the dielectric medium is sigma is far lesser than that of omega epsilon, or sigma by omega epsilon is less than that of 1. Then next case, lossy dielectrics. As the name itself resembles us that lossy represents there must be some loss which is exist in that medium. So name is given by lossy dielectrics, hence sigma is not equal to 0. See, if you observe here lossless dielectrics and lossy dielectrics, in the lossless dielectrics case sigma equal to 0, whereas in the lossy dielectrics case sigma is not equal to 0, and epsilon is replaced by epsilon naught into epsilon r, and mu is to be considered as mu equal to mu naught into mu r, right? So these are the two cases we are going to learn in this particular lecture, right? So electromagnetic wave or uniform plane wave is to be propagating in lossless dielectrics and followed by lossy dielectrics. Along with these two, one more class is there, that is classification is there, practical dielectrics. Practical dielectrics. So in this lecture, we have learnt how the electromagnetic wave is to be propagating in lossless as well as the free space medium we have discussed. In this lecture, we are going to learn practical dielectrics medium. Along with that, lossy dielectric medium propagation is to be analyzed, right? So in order to learn this lossless dielectrics, we must be assume sigma equal to 0, epsilon and mu are to be considered as respectively epsilon naught into epsilon r and mu naught into mu r. For a lossy dielectrics, sigma is not equal to 0 and epsilon equal to epsilon naught into epsilon r, mu is nothing but mu naught into mu r, right? And last case is to be considered as good conductors. For a good conducting medium, sigma is approximately equal to infinity, whereas epsilon is nothing but epsilon naught into epsilon r, and mu is considered to be as mu naught into mu r. And the condition which is to be considered for good conducting medium is sigma is far greater than that of omega epsilon. Means at very high conductivity case, at low frequencies case, medium behaves as good conducting medium. Or instead of considering this sigma is far greater than that of omega epsilon, we are also considered as sigma by omega epsilon is far greater than that of 1 case medium is considered to be as good conducting medium, right? So keep in mind this. These are the fundamental assumptions in order to analyze all the waves which are to be propagating in the respective medium, right? So next, and determination of attenuation and phase constants are also we have learnt in the previous lecture. So that is from the alpha, means propagation constant gamma, which is to be constitutes attenuation constant alpha plus phase constant as beta, right? So gamma equal to alpha plus j beta, and from the wave characteristics equation, this alpha plus j beta is nothing but j omega mu into sigma plus j omega epsilon under root, right? So propagation constant gamma constitute attenuation constant alpha and the phase constant beta, which is expressed in terms of all the characteristics of the electromagnetic wave, or omega is the frequency, angular frequency, mu be the permeability of the medium, sigma conductivity of the medium, and epsilon is permittivity of the medium, right? So depending upon this, alpha and beta are to be evaluated. That is, alpha is nothing but attenuation constant, which is given by here omega root over mu epsilon by 2 root over 1 plus sigma by omega epsilon whole square minus 1. And for beta, that is nothing but phase constant, which is equal to omega root over mu epsilon by 2 into root of 1 plus sigma by omega epsilon whole square plus 1, right? And in order to estimate the wave motion in the different types of medium, we are going to have these are the following three parameters. In order to determine the propagation constant gamma, we need to know attenuation constant alpha and the phase constant beta. So these are the two fundamental equations for alpha and beta for the constants as attenuation and phase, right? And along with this propagation constant, we also have one of the term called intrinsic, that is intrinsic impedance, or eta is nothing but eta equal to j omega mu by sigma plus j omega epsilon under root, right? So now to analyze the wave motion or the propagation of the different medium, we are consider the basic two fundamental formulas as propagation constant gamma equal to alpha plus j beta equal to under root of j omega mu into sigma plus j omega epsilon, and intrinsic impedance eta is nothing but generally it is the ratio of electric field strength to the magnetic field strength, and it is expressed in terms of wave characteristics as j omega mu by sigma plus j omega epsilon, right? So these are the two fundamental formulas in order to analyze the waves or which are to be propagating in different medium, right? So this already we have analyzed, already we have learned. Just a revision purpose, we is this one, uniform plane waves in lossless dielectrics. So in the dielectric medium, we are going to analyze in the dielectric medium, we are going to analyze the wave propagation in three different cases. One is lossless, next one is lossy, and third one is practical dielectrics, right? So first case, lossless dielectrics. As the name itself resembles that lossless, there is no loss in the, hence this lossless dielectric medium is also called as perfect dielectric medium, right? So in order to analyze this one, what is the condition we need to consider here? Sigma is lesser than that of omega epsilon, or sigma by omega epsilon is far lesser than that of 1, right? So this is the condition we have to consider, and this already we have analyzed. The characteristics of the waves are to be considered as sigma equal to 0, omega epsilon equal to epsilon naught into epsilon r, and mu equal to mu naught into mu r, right? So sigma equal to 0. In order to analyze this one, as we know that first parameter we are going to consider is here propagation constant gamma equal to alpha plus j beta equal to j omega mu into sigma plus j omega epsilon under root, right? So in this, you just substitute sigma by 0 in this case. Then gamma equal to alpha plus j beta equal to j omega mu into j omega epsilon. If you substitute sigma by 0, then j omega mu into j omega epsilon is left out. Then j omega epsilon, if you take it as out of root, then it becomes j omega into root mu epsilon, where this gamma is to be constituted as the resultant one in terms of attenuation constant alpha and the phase constant as beta, right? So alpha is the real term, whereas beta is the imaginary term. Now if you observe here, this resultant will be consisting of 0 plus j omega into root mu epsilon. Right? So now compare both sides, real and imaginary terms. If we equate real terms, alpha equal to 0 and beta equal to omega root over mu epsilon. Right? So alpha equal to 0. What is this alpha? Attenuation constant. There is no reduction in the amplitude. Hence, there is no loss in the signal. Then, the medium is to be considered as your lossless dielectric or perfect dielectric. Right? So, alpha equal to 0, then beta is to be considered as omega root over mu epsilon. Right? So alpha equal to 0, beta equal to omega root over mu epsilon. Then from that, gamma can be written as omega root over mu epsilon. Right? So next, velocity equal to omega by beta, and which is to be considered as root over mu epsilon. Right? Then lambda equal to, and where lambda is said to be wavelength, and it is to be considered as 2 pi by beta and eta. As we know that eta formula, that is intrinsic impedance, nothing but j omega mu by sigma plus j omega epsilon. Right? In this case, if we substitute sigma by 0 here again, so what is that we are going to get? J omega mu by j omega epsilon root over. So this j omega gets cancelled. Root of mu by epsilon is left out, eta. Right? There is no imaginary part. Right? So intrinsic impedance of the lossless dielectric medium is having only real part. There is no imaginary part. Right? As we know that eta in general can be expressed as eta equal to E by H, which is equal to root over mu by epsilon. Now from the statement, E and H, electric field intensity E and the magnetic field intensity H are in the time phase with each other. Why? Because there is no imaginary term. If you write the phase function for this, phi equal to tan inverse of imaginary, there is no imaginary, by real term, root over mu by epsilon, nothing but 0. Hence, electric field E and the magnetic field H are differed by 0 degrees phase shift. Right? Hence, E and H are in time phase with each other, or electric field strength E and the magnetic field strength H are to be in phase in the lossless dielectric medium. Right? So as alpha equal to 0, sigma equal to 0, then lossless dielectric medium is also called as the perfect dielectric medium. Right? So next one. So in this lecture, the continuation part here, we are going to learn the uniform plane waves in the lossy dielectrics. Right? As we have seen, the dielectric medium is to be analyzed in 3 different cases. First one is lossless, next is lossy, and the third case is to be as practical dielectric medium. So first we have analyzed lossless dielectric medium. There we will assume as sigma equal to 0, then epsilon equal to epsilon naught into epsilon r, then mu equal to mu naught into mu r. Depending upon that, alpha equal to 0, beta equal to omega root mu epsilon, then eta equal to root over mu by epsilon is to be obtained. Now, second case is here, uniform plane waves propagation in lossy dielectric medium. Right? So as the name is itself represents, a lossy dielectric is a medium in which electromagnetic wave loses power as it propagates due to poor conduction. Why? Because as this sigma is not exactly equal to 0, not exactly equal to infinite, means there must be some loss in the signal. There must be some loss in the medium. Hence, the medium is to be considered as lossy dielectric medium. Right? So, a lossy dielectric is a medium in which electromagnetic wave loses power as the wave is to be propagates in due to that poor conduction. Right? Next, a lossy dielectric is a partially conducting medium, means imperfect dielectric or imperfect conductor. Hence the name partially conducting medium, as the sigma value is not exactly equal to 0 or not exactly equal to infinite. Hence the name imperfect dielectric or imperfect conductor as lossy dielectric. Right? So with sigma is not equal to 0. If sigma is not equal to 0, alpha is also not equal to 0. If alpha is not equal to 0, means there must be some attenuation in that particular medium. Right? Hence the name lossy dielectric. Okay. So as we are going to analyze this uniform plane wave or electromagnetic wave propagation in the lossy dielectric medium, we need to consider propagation constant gamma and intrinsic impedance eta. Right? So propagation constant gamma equal to alpha plus j beta, which is equal to under root of j omega mu into sigma plus j omega epsilon. As sigma is not exactly equal to 0, by rearranging the terms, we are going to have alpha and beta equations separately. Right? So from this, if we take here, means gamma equal to j omega mu into sigma plus j omega epsilon. We know that. Now from this, if we take j omega mu into j omega epsilon as common from this, then 1 plus sigma by j omega epsilon under root. Right? So from this, we are going to write j omega root over mu epsilon into root of 1 minus j. Why? Because this 1 by j can be written as 1 by j can be written as minus j. How this minus j has come? Means if you rationalize this one, 1 by j with 1 by j equal to j by j into j. So if you get cancel this j and this j, this equation remains the same. Now from this, j by j square, hence j square value is minus 1, hence this can be written as minus j. Right? So instead of considering 1 by j, if you write minus j, also there is no change in that equation. Right? Hence, if you substitute 1 by j by minus j, then this equation remains as j omega root mu epsilon root over 1 minus j into sigma by omega epsilon as gamma. Right? So that is the equation to be considered as here gamma equal to alpha plus j beta, which is equal to j omega root mu epsilon into 1 minus j into sigma by omega epsilon. Right? So if you multiply this one inside, here is j, means this term becomes imaginary term. Again here j is there and here j is there. If you multiply these two, j square value becomes minus 1, then this term is to be considered as a real one. What is that real term is called here? Attaination constant alpha. So for a lossy dielectric medium, alpha must be there. Hence the name lossy dielectric. Right? So j omega root mu epsilon root over 1 minus j into sigma by omega epsilon. Okay? Now to analyze the wave propagation, means how the electric field and magnetic fields are differed by. How much is the phase shift between electric and magnetic fields in the lossy dielectric medium? Means depending upon this intrinsic impedance eta, we are going to analyze. The formula is given by here, eta equal to root over j omega mu by sigma plus j omega epsilon. In general, this eta can be written as along with the magnitude and the phase angles are to be considered as magnitude is given by modulus of eta and the phase angle to be written with respect to the theta. And intrinsic impedance, as we know that impedance and resistance both can be exhibited resistance property, and hence this intrinsic impedance eta to be measured in the ohms. Right? So the characteristic equation for the intrinsic impedance eta, and it is given by root over j omega mu by sigma plus j omega epsilon. Right? So from that, as we know that eta equal to j omega mu by sigma plus j omega epsilon root over, then if you take in the numerator j omega mu by the denominator j omega epsilon, if you take as common, then 1 plus sigma by j omega epsilon under root. right? So this j omega gets cancelled. Root of mu by epsilon into 1 by 1 minus j into sigma by omega epsilon, right? Eta, and it is to be measured in ohms, right? So based upon that, this eta can be given by root over mu by epsilon into 1 by root over 1 minus j into sigma by omega epsilon. As we know that 1 by j, this 1 by j can be written as minus j, as we have seen in the previous analysis. Then eta to be as root over mu by epsilon into root of 1 by 1 minus j into sigma by omega epsilon. Okay, so from that we are going to write the equation for the phase angle. Why? Because in general this eta to be is given by, is the ratio of electric field strength E to the magnetic field strength H, right? So in order to write the equation eta equal to E by H, how much phase is differed by between this E and H, from that we are going to write this equation. Like eta equal to, so for this real term no need to write anything. For the imaginary 1 by 1 minus j into real some term is there. So from that, for that we are going to write 1 by, for this root first we are going to write it as for root theta formula it is theta by 2, hence we can square it as 1 by 2, and 1 by root over means 1 by some imaginary term, complex function is there. For that we are going to write it as 90 minus that function. So 90 can be written as here pi by 2 minus tan inverse of imaginary. So that function can be written as tan inverse of imaginary function as minus j sigma by omega epsilon by 1, this thing, and 1 by the tan inverse of term can be considered. So this 1 by this term becomes tan inverse of omega epsilon by sigma. Basically it is tan inverse of sigma by omega epsilon, and this should be written in the denominator term, means it will be considered as in the reverse case. Hence theta n is equal to 1 by 2 into pi by 2 minus tan inverse of omega epsilon by sigma. Right? So and theta to be measured in radians. Right? So as we know that this theta n is ranging from 0 to pi by 4. Pi by 4 means how much it is the angle? 45 degrees. Means the electric field strength E and the magnetic field strength H are to be differed by 45 degrees phase angle in the lossy dielectrics. Okay. How it is to be written? Means the range of this is to be written. Means this angle is depends on the properties of the lossy dielectric medium as well as the frequency of a signal. Right? Why? Because theta n is to be written as 1 by 2 into pi by 2 minus tan inverse of omega epsilon by sigma. So epsilon and sigma are the characteristics of the medium, and omega be the angular frequency of the medium. Hence this angle means that theta n is depends on the properties of the lossy dielectric medium as well as the frequency of a signal. Right? So next, so to find the angle means the range of this angle, in order to find that theta n is to be considered as theta n is equal to 1 by 2 into pi by 2 minus tan inverse of omega epsilon by sigma. Right? Now for this, for low frequency signals means for low frequency signal if we substitute omega by 0, omega becomes very small. Means we assume omega equal to 0, then theta n is to be considered as 1 by 2 into pi by 2 minus tan inverse of omega as 0 is nothing but which is equal to 1 by 2 into pi by 2 minus tan inverse of 0 is nothing but 0. This 1 by 2 into pi by 2 can be given by pi by 4. Nothing but 45 degrees. Okay. So at very low frequencies, if you are assuming omega equal to 0, then theta n becomes 45 degrees. Similarly, at very high frequencies, means if you assume omega equal to infinity, then theta n is equal to 1 by 2 into pi by 2 minus tan inverse of, if you substitute omega by infinity, tan inverse of infinity. So the tan inverse of infinity value is pi by 2, hence 1 by 2 into pi by 2 minus pi by 2, then these two gets cancelled, which is equal to 1 by 2 into 0 becomes 0 degrees. Right? So this is the way the angle in the lossy dielectric is ranging from 0 to 45 degrees. Right? So as we know that the intrinsic impedance of the medium, in this case the electric and magnetic field intensities are differed by 45 degrees phase shift. Right? So this is the way the uniform plane wave propagation or the electromagnetic wave propagation in the lossy dielectric medium is to be analyzed. Right? So now to analyze, first we are going to consider the propagation constant gamma, which constitutes attenuation constant alpha and the phase constant beta, and intrinsic impedance of the medium as eta. Right? So depending upon those two, we are going to have attenuation constant alpha, phase constant beta, then propagation constant gamma, and the electric and magnetic field intensities are differed by 45 degrees in the lossy dielectrics. Okay? So, next is uniform plane waves in the practical dielectrics, means electromagnetic wave propagation in the practical dielectrics. So two cases we have analyzed, that is first case is lossless dielectric medium and the next one is lossy dielectric medium, and the third case is to be practical dielectrics. So uniform plane waves in practical dielectrics. So in this case, in order to analyze this one, for a perfect dielectric means, as we know that for a perfect dielectric means insulating material sigma is to be 0. So for a perfect dielectric medium sigma equal to 0, but for a practical dielectric sigma is not exactly equal to 0. So that is the case. We need to consider the condition as sigma by omega epsilon is lesser than that of 1 or sigma is far lesser than that of omega epsilon. Okay. So in order to analyze, we must consider the condition as sigma by omega epsilon is far lesser than that of 1. Next, now to know the wave propagation in the practical dielectrics, first we have to consider the propagation constant gamma, that is alpha plus j beta equal to j omega root over mu epsilon root of 1 plus sigma by j omega epsilon. Right? So consider the radical term. So why it is said to be radical term? As we know that gamma equal to alpha plus j beta equal to root over j omega mu into sigma plus j omega epsilon. Now from this, if we take j omega mu into j omega epsilon as common, 1 plus sigma by j omega epsilon root over. Now from this, j omega root mu epsilon into root over 1 plus sigma by j omega epsilon has to be considered as propagation constant gamma. Right? So gamma equal to alpha plus j beta equal to j omega root mu epsilon into root over 1 plus sigma by j omega epsilon. Right? So consider this formula, and in this we just leave about this j omega root mu epsilon and consider inside the root over term, that is 1 plus sigma by j omega epsilon as a radical term. Right? So consider the radical term, means this is the term, and mathematically using binomial theorem. In order to write in order to apply this binomial theorem, we just consider here radical term as root over 1 plus sigma by j omega epsilon. So that according to the binomial theorem, that statement is given by 1 plus x whole power n is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus n into n minus 1 into n minus 2 by 3 factorial into x cube plus and so on. Right? So here where modulus of x is less than 1. Right? So consider this is the fundamental mathematical binomial theorem. Now in that in place of x, we just consider here means 1 plus x whole power n. So here in place of x, 1 plus x means sigma by j omega epsilon and whole power n. N is nothing but here 1 by 2. So root over this 1 plus sigma by j omega epsilon means this total term can be written as 1 plus sigma by j omega epsilon whole power 1 by 2. That root can be written as 1 by 2, power 1 by 2, right? So if modulus of x is less than 1 and n is equal to 1 by 2 according to this, then neglecting the higher order terms, right? So higher order terms means x square, x cube, x power 4 and all terms are to be neglected. Why? Because if modulus of x is less than 1, this is the formula is applicable, right? So if modulus of x is less than 1 and n is equal to 1 by 2, you're going to neglect all the higher order terms. Then 1 plus sigma by j omega epsilon whole power 1 by 2. See, 1 plus x means in place of x, we just consider sigma by j omega epsilon whole power n is nothing but 1 by 2, which is equal to 1 plus nx. What is that value of n here? From this 1 by 2 into x is nothing but sigma by j omega epsilon, right? So upon expanding this equation, 1 plus 1 by 2 into sigma by j omega epsilon, then gamma is to be, means in place of this radical factor root over 1 plus sigma by j omega epsilon, we just write this as 1 plus 1 by 2 into sigma by j omega epsilon. Then gamma can be written as here alpha plus j beta equal to j omega root over mu epsilon into 1 plus sigma by 2 j omega epsilon, right? So now from that we are going to find alpha and beta, right? As we know that gamma equal to alpha plus j beta equal to j omega root over mu epsilon into 1 plus sigma by j 2 omega epsilon. Previous term, if you observe, 1 plus sigma by j 2 omega epsilon. Okay, so now from this, multiply this term j omega root mu epsilon with inside the factor, then j omega root mu epsilon plus j omega root mu epsilon into sigma by j 2 omega epsilon, right? So this j omega gets cancelled and j omega root mu epsilon plus then this root mu is as it is mu epsilon into sigma by 2 into this term inside root if we take this as epsilon square. So this epsilon square and epsilon gets cancelled. Then j omega root mu epsilon plus sigma by 2 into root of mu by epsilon is left out. So that is gamma. So gamma equal to alpha plus j beta equal to sigma by 2 root over mu by epsilon plus j omega into root mu epsilon. Means this is the real term is nothing but alpha and this is the imaginary is nothing but beta, right? So gamma equal to alpha plus j beta equal to sigma by 2 root over mu by epsilon plus j omega root mu epsilon, right? So both sides if we compare real and imaginary terms, now real term alpha is nothing but root over sigma by 2 root over mu by epsilon and the beta phase constant is nothing but imaginary term that is omega root over mu epsilon, right? So alpha and beta. Now in order to find the phase difference between electric field strength and the magnetic field strength, we need to consider another characteristic parameter as intrinsic impedance eta, right? So root over j omega mu by sigma plus j omega epsilon, which is nothing but means if you take here j omega epsilon as separate from this, then 1 plus sigma by j omega epsilon. Now from this j omega gets cancelled. Then eta equal to root over mu by epsilon into 1 plus sigma by j omega epsilon whole power minus 1 by 2. Why? Because this square root term is in the denominator term. If it is there in the numerator, we just consider 1 by 2. Now it is in the denominator, hence we are going to consider it as minus 1 by 2. Right? So eta equal to root over mu by epsilon into 1 plus sigma by j omega epsilon whole power minus 1 by 2. Right? So as we have analyzed, as we will apply their binomial theorem for the numerator function, similarly here also using that binomial theorem. So consider again, this is the radical term. So for this radical term, we'll apply binomial theorem. So using binomial theorem means formula is given by 1 plus x whole power minus n is equal to 1 minus nx plus n into n minus 1 by 2 factorial into x square minus n into n minus 1 into n minus 2 by 3 factorial into x cube plus and so on. Right? So here also we'll be neglecting all the higher order terms. Now based upon that, means as x equal to sigma by j omega epsilon is very small as compared to 1, and by neglecting the higher order terms, that is 1 plus x whole power minus n becomes 1 minus nx. Now what is the value of n here? 1 by 2. So eta equal to root over mu by epsilon into, in place of radix term, we just written that as 1 minus sigma by j2 omega epsilon. Right? So multiplication between these two. So hence it becomes root over mu by epsilon, then 1 minus sigma by j2 omega epsilon. So this 1 by j can be written as minus j, as we know that 1 by j is nothing but minus j, and already in the formula itself negative is there. Then this multiplied, then it becomes plus, then 1 plus j into sigma by 2 omega epsilon whole ohms. Right? Why? Because this intrinsic impedance, no, so it should be measured in terms of ohms. Right? So for this term we are going to write the equation again. So the same thing we are going to get how the electric field strengths and the magnetic field strengths are to be differed, as we have analyzed in the case of lossy dielectric medium. Right? So in the first, means there are three cases in the dielectric materials. One is lossless, second one is lossy, and in the third case as practical dielectric case. Right? So in the lossless case, directly we are assuming sigma by 0. In the lossy case, sigma is not equal to 0 case, we'll consider there as attenuation constant alpha and the imaginary constant as separately. In the practical case, it is said to be sigma is not equal to 0, and the condition we have considered is sigma by omega epsilon is far lesser than that of 1. Now from this, attenuation constant alpha and the phase constant beta are to be evaluated, and similarly intrinsic impedance of the practical dielectric medium is also to be analyzed. Okay? Now, so there is a one Maxwell's equation, that is del cross h bar is equal to j plus dou d bar by dou t. What is this Maxwell's equation? That is to be obtained from Amperes Circuit Law. Amperes Circuit Law. So according to this Amperes Circuit Law, del cross h bar is equal to j plus dou d bar by dou t. As we know that this j is nothing but conduction current density, and it is given by sigma into E bar, and in place of D if you substitute epsilon into dou E bar by dou t. And for a time varying fields, we just consider time varying fields dou by dou t is replaced by j omega, hence sigma into E bar plus epsilon into j omega into E bar. Okay, so sigma into E bar plus j omega epsilon into E bar. If you take in between these two, E bar as common, sigma plus j omega epsilon. This is del cross h bar. So that we have written here, del cross h bar is equal to E bar into sigma plus j omega epsilon. Right? Or instead of writing this much elaborately the equation, then del cross h bar is equal to jc plus jd. What is this jc? Means conduction current density, and jd resembles displacement current density. So as we know that jc is equal to sigma into E, jd is nothing but dou d bar by dou t, or epsilon into dou E bar by dou t. Now this, if you consider the ratio between conduction current density to displacement current density, So JC by JD is equal to, as we know that the formula for JC is sigma into E bar, and for this is j omega epsilon into E bar. Now E bar gets cancelled. Sigma by j omega epsilon is to be obtained as it is the ratio of JC to the JD, conduction current density to the displacement current density, right? So if we consider the angle measurement as like this, here is the JC and here it will be the JD, then the loss tangent is to be considered as like this. This is the theta. Theta is said to be loss angle, where theta is said to be loss angle and sigma by omega epsilon is said to be loss. Tan theta equals sigma by omega epsilon is said to be loss tangent, right? So now to calculate loss angle and the loss tangent, see, loss tangent of the dielectric is given by tan theta equal to sigma by omega epsilon. Tan theta, no, side adjacent side to the from this table triangle, if you want to calculate the tan theta, so that is the tan theta equal to sin theta by cos theta. So sine means we have to measure it as opposite side, and cosine means adjacent sides. So sine by cosine, if you consider the base theory as JC to the JD, then the JC by JD, the ratio is given by tan theta, so which is equal to sigma by omega epsilon, right? So loss tangent, where tan theta equal to sigma by omega epsilon is said to be loss tangent, and the theta, from this theta equal to tan inverse of the sigma by omega epsilon, then where theta is said to be loss angle, right? So from this, the ratio of conduction current density to the displacement current density, we are going to have the two terms called loss angle and the loss tangent of the dielectric medium, right? So how will identify the given medium is a type of dielectric medium or a good conducting medium? Means the conditions are to be satisfied for both is, if sigma is far lesser than that of omega epsilon, means the loss tangent is small and medium is said to be good dielectric, right? So sigma is far lesser than that of omega epsilon means sigma is less and omega is more. At low conductivity case, at high frequencies case, medium behaves as good dielectric medium and the loss tangent is to be very small. Okay. So similarly, if sigma is far greater than that of omega epsilon, means if sigma is more and omega is to be less. At very high conductivity case and with very low frequencies case, medium behaves as good conducting medium where loss tangent is to be high. Right? So need to remember these 2 points, which is very important in order to identify the given medium is the type of dielectric or conducting medium. So firstly, the 2 important points we need to remember is here sigma by omega epsilon is far lesser than that of 1 and sigma by omega epsilon is far greater than that of omega epsilon. So sigma by omega epsilon is far lesser than that of 1 case good dielectric medium. This is the case good conducting medium, right? So if sigma is far lesser than that of omega epsilon, loss tangent is very small and the medium is said to be good dielectric. And if sigma is far greater than that of omega epsilon, the loss tangent is very high and the medium is to be a good conducting medium, right? So what we have learned in this particular lecture as 3 cases of dielectric medium we have analyzed, means the uniform plane wave propagation in 3 cases of dielectric medium we have analyzed. Firstly, lossless dielectrics, and the second case is lossy dielectrics, and third case is practical dielectrics. In the next class we are going to learn the electromagnetic wave propagation in good conducting medium, right? So in order to learn, identify the given medium is dielectric medium or conducting medium, we need to know what is the value of loss tangent and the loss angles, right? To measure these 2 parameters, we need to consider the ratio between conduction current density to the displacement current density. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.